These are the video notes for the activity 2.7, how old am I? The purpose of this activity is to use half-life of a radioisotope to determine the amount of sample remaining after a certain period. Remember, we can also use half-life to determine the age of a sample, as well as use the sample and its age to determine the half-life of it. So we'll be going through all of those with the practice later. Okay, so a little bit of background. Just like living things, unstable atoms will break apart or decay. The rate at which a radioisotope decays is called the half-life. Half-life is defined as the time it takes for half of a sample of a radioisotope or atoms to decay or disappear. No matter what the size of the sample, the half-life for any substance remains constant. Variables such as temperature, pressure, or changes in the chemical composition of the surrounding material will not affect the rate of decay. It is therefore useful to use half-life to determine the age of objects containing a radioisotope or atom. This process is called radioactive dating, just like what we did in the radioactive dating game PhET Lab. An example of this process is used in the movie Jurassic Park, where archaeologists in Jurassic Park use carbon-14 dating as a means for determining the age of a dinosaur bones they've discovered. In reality, they don't actually use carbon-14 dating because it does not go as old as dinosaur bones are, but they use it because it's easy to relate. My apologies. When doing calculations involving half-life, we make a table like the one below, listing the amount of sample or radioactivity at the start and after each half-life. This table will allow you to relate the number of half-lives, the length of each half-life, the total amount of time, and the amount of sample or radioactivity left for each problem, as well as how much you start with. So, there are several steps to go with this. The first is always figure out what you're looking for, so determine what you're solving for. The second step is to determine the number of half-lives that have occurred, if possible. If you are solving for the half-life or how long the half-life is, you will not be able to do step 2. The third is to make the table here. And the fourth is to always start with 0 half-lives and 0 time. So here and here will always be 0. Your initial sample is sometimes given, usually given. And then you remember with each half-life, the amount of sample always decreases by 1/2. So you're going to divide by 2 each half-life. So we're going to look at an example of this process. So, example 1, strontium, a common product of thermonuclear bonds, has a half-life of 28 years. So that is our T 1/2. If 400 grams of strontium-90 is produced in a thermonuclear explosion, how much will be left after 112 years? So grams is an amount, so this is what we're starting with. And then 112 years is how long this will go. So we're going to go from time 0 to 112 years. So we want to find how much we have left after 112 years. The second step is to determine the number of half-lives. So the number of half-lives is going to be the total time, so 112 years. And you're going to divide by how long each half-life is, so 28 years. When you do that math, you will see that this is 4 half-lives. Okay. Your third step is to draw the table, which in the notes are done for you. When you do the practice, you will have to draw them yourself. And you start filling it in. Step 4 said the 0 for number of half-lives and time is where you always start. The amount of sample we start with is 400 grams. Now, if we don't want to rewrite the units every time, we would put the units at the top of our table with the table column headings. And then our time is in years. Okay? And so we want to know from time 0 to 112 years later, how much does this decay? And we know that that is going to go through 1, 2, 3, 4 half-lives. So each half-life is 28 years, so I add 28 each time. So 28 and 0 is 28. Adding 28 again is 56. We add 28 one more time is 84. And to check your work, you would see that 28 and 112, 28 and 84 is 112. Okay, then our last step is to divide our sample in half, as many half-lives as we have. So we're going to divide it in half 4 times. So 400 divided by 2 is 200. Divide it in half again is 100. Half again is 50. And then a final time is 25. So that tells us that 25 grams remains after 112 years. Example 2 states, what is the half-life? So we're looking for half-life. So we're looking for this T1 half. Of palladium, what is the half-life of palladium-103 if after 51 days a sample with a radiation level of 1800 counts has decreased to 225? So counts is the unit that we use to measure the radiation level. Okay, so first step, we know what we're solving for is half-life, which means we don't do step 2 because we do not know what the half-life is. Then step 3, we're going to make a table. So we know and then step 4 is 0, 0, and then the amount we start with is 1800. And then we're going to write in our units, which was count, and then for the time, it is days, because we see that in the equation, 51 days. So we know we're going to go from 0 to 51 days. And at 51 days, we will be at 225 counts. So to get from 1800 to 225, that would help us figure out the half-life. And so we can't do half-lives yet here, and we can't do the time, so we have to work backwards. So in the first problem, we set up half-lives, then we did time, and then we did the amount of sample left. Well, since we don't know step 2, we're going to start with the end and work our way back. So amount of sample left, we're going to divide this in half until we get to 225, and that'll tell us how many half-lives we have. So 1800 divided by 2 is 900, and then divide 900 by 2 is 450, and we see 450 divided by 2 is 225. And so we see we divide it in half 1, 2, 3 times. That tells us that there's 1, 2, 3 half-lives. Okay, so now we have enough information knowing how many half-lives in total time, we can figure out the half-life length. So T1 half, or the half-life, is equal to, going to take 51 days, because that's the total time, and we're going to divide it by the number of half-lives, which is 3 half-lives. And that'll give us our answer. So 51 divided by 3 is 17 days, which is how long our half-lives are. Okay. After this, you will practice with the practice problems down here. Okay. And then you can check your work in class. Thank you, everyone.